We define an alternating series if every other term is positive and every other term is negative. So we have a positive term, a negative term, positive term, negative term, right? Notation is really important on that. We always want our actual function that we're looking at to be positive. I know Ted talked about that the other day. So looking at something, not that one. Yeah. All right. So looking at something. Where a sub n is our actual function, and this is what we want to actually be positive. Our negative comes in from writing it like this, where it's going to alternate. So when I plug in 1, negative 1 to the first power is going to be negative 1. Negative 1 squared is a positive 1, so it's going to bounce back and forth. We could also write it which the only difference between these two is what?
Starts with positive.
One starts with positive, one starts with negative. This one, when I plug in my first value for n, negative 1 to the first power is negative 1. This one, I'm adding 1 to it, so negative 1 squared. So my first term is positive. This first term is negative. So just a difference in notation. So looking at the different types of tests that we have for an alternating series. First, just want to look at one series that we've already dealt with, just 1 over 2 to the n. And we know what type of series is that?
Geometric.
It's geometric, so do I know it converges?
Yes.
I know 1 over 2 to the n converges because I can rewrite this like that. This is less than 1, so it converges. So just listing out a few of the terms. If I put in 1, I get a half. Put in 2, I get a fourth. I put in 3, an 8, a 16th, a 32nd, so on and so forth. Right? Everybody believes me? Alright, so if I look at this as an alternating series, so let's say I have 1 over negative 1 to the n plus 1, 1 over 2 to the n. So everybody agrees with me? It's properly written alternating series. So what do you think? I know this one converges. What do you think about this series in comparison to this series? You think it's going to be bigger, smaller, converge, diverge? What do you think?
Converges.
You think it converges? Why? Intuitively, could you tell me why?
You just compare it to the geometric.
Well, let's list out a few of the terms.
It would just be subtracted.
You're subtracting a piece off of it every single time. So this series, in essence, is going to be smaller than this series. Okay? So if we go through and we just list out a few of the terms, it'd probably be easy to see that. Whenever I stick 1 in, negative 1 squared is going to be a positive 1. So my first term is going to be positive, so I do get a half. My next term is going to be negative 1 to the third, so it's going to be a negative 1/4. So minus a fourth, plus an 8, minus a 16th, plus a 32nd, so on and so forth. So this series looks exactly like this one does, but instead of adding all the terms up, I'm adding a set of terms and subtracting one. Adding and subtracting each time. So this one is actually smaller than this series is overall. So this one converges, this one converges. So it takes us, basically looking at our first test, the, what is it called? No? The absolute convergence test. So if you read in your notes, the absolute convergence test tells you that if the absolute value of your series converges, then your series converges, your alternating series converges. So if we take the absolute value of this, so we have the sum, n equaling infinity, n equaling 1 to infinity, the absolute value, what is the absolute value of this?
1 over 2 is.
Just 1 over 2 to the n, because the absolute value of -1, just everything goes to positive. So that actually just does give us 1 over 2 to the n back, which you told me from the get-go. It does converge because it's geometric. Okay, so that's the absolute convergence test. Tells us that if the absolute value of our series converges, then the alternating series will also converge. Okay, which I hope makes sense from what we looked at right here. If it's alternating, then we're just subtracting off a piece every single time, right? So if one converges, remember when we do like direct comparison, we always find a series that's smaller than it. So if the bigger one converges, the smaller one also does. Does that make sense? All right. So that is the absolute comparison. Absolute convergence test. We good? Okay. So from there, we also have what's called the alternating series test that says that if we have a non-increasing sequence of positive terms such that the limit of the terms goes to 0, then we know that the alternating series will also converge. So it's almost like the nth term test in a way. But we do have that one extra stipulation that it does have to be non-increasing. So if we look at, again, the same exact series, just doing a different test on it. And we're just looking at our a sub n part, which is just the actual function itself, 1 over 2 to the n. So we can do the nth term test on it as long as it's non-increasing. So how do we show something's non-increasing? Do what? Well, non-increasing. What does it mean to be non-increasing?
Staggering decrease.
It goes low for a while, and then it goes back up, and then it goes back
Stair step down.
Right.
As long as it goes down.
Right. Okay. So to say that it's non-increasing, or it means that a sub n is going to be less than or equal to a sub n plus 1. Alright, so it's just a little bit different than straight decreasing. Straight decreasing says that a sub n... Did I write that backwards?
No.
No, I did write that backwards. Hang on, so we're looking at non-increasing. So if it's non-increasing, that means it's not going up. So a sub n is going to be greater than or equal to our next term. So it's non-increasing, so it has to go down. So if I plug in 4, that has to be bigger than if I plug in 5. Or equal to it. Does that make sense? I know this got crazy before. It's the non-increasing, non-decreasing, decreasing, increasing. So we have to be sure that it is non-increasing. So a sub n has to be greater than or equal to a sub n plus 1, which we could show by doing 1 over 2 to the n is greater than or equal to 1 over 2 to the n plus 1. Y'all believe me? Yeah, so 1 over 2 to the n is greater than or equal to 1 over 2 to the n plus 1. I know they're both positive, so I can multiply without causing any damage. So I get 2 to the n plus 1 is greater than or equal to 2 to the n. So using my natural log trick, n plus 1 times the natural log of 2 is greater than or equal to n times the natural log of 2. Divide both sides by the natural log of 2, which is positive, so I don't mess anything up. And I get n plus 1 is greater than or equal to n. Subtract off n, so 1 is greater than or equal to 0, always. So this is true, so it is non-increasing, so this does work. Alright, so now it's basically just the nth term test. As long as the limit of them goes to 0, then we know the alternating series itself converges. So the limit as n goes to infinity of 1 over 2 to the n, and what is that? What is the limit as n goes to infinity? It is 0, because the bottom's going to infinity. So the whole thing goes to 0. So this is 0. So by the alternating series test, we can see that since this converges, then our alternating series itself converges. We good? So either test worked on this one. The difference comes up where the absolute convergence test just says that if the absolute value of the series converges, then the whole thing converges. But it doesn't say anything about divergence. So if we have where the absolute value diverges, then we have the alternating series test. Do you want me to look at the harmonic series? Do you think I have time to do that?
Yeah, probably not.
Probably not?
That's the same one.
Alright. Does that make sense? Does anybody have any questions about that? What's up?
On the alternating series test, it says it converges if the 2 conditions are met. One of them is a, n plus 1 must be greater than or equal to, or less than or equal to a to the n.
Right, which is exactly what I had up here. I just wrote it backwards. A sub n is greater than or equal to a sub n plus 1, which is the same thing as a sub n plus 1 is less than or equal to a sub n. Is that the condition I said? So this is just showing that it's non-increasing, which is what we showed.
But on an alternating series, depending on where it starts, wouldn't that be false?
Of just the a sub n itself.
2 weeks from today?
Remember we wrote it second.
Sure it does. Alright, so 2 weeks from today. Second, I know that y'all have been a really good class. I think you deserve a break, so I want to take next Friday off. So next Friday, we'll go ahead and take it off. And 2 Fridays from now, we'll have a test. I don't think we're going to squeeze a quiz in this time. Maybe I'll throw in